Hey guys, today we're going to talk about comparing two quadratic functions. So we're going to take two quadratic functions in different forms. All right, so if you remember, we study EGTC, all right, equations, graphs, tables, and context for every function. So we're going to take a look at a comparison between, in this example, a quadratic where I've only got the equation and the graph versus a quadratic where I've only got the table. And I'm actually going to turn the graph off, all right? Here we go. All right. So what we're going to try to accomplish here is, can we find the four main features of quadratics with or without the graph? Yesterday's work was all about the graph. And today we're seeing, do we really need the graph for everything? Right. I want to remind you of the four main features that we studied. All right. With the first one being the y-intercept. All right. Your second main feature we said were the roots, all right, the roots, aka the x-intercepts, all right. After that, we also looked at the vertex, all right, vertex. And last, we looked at the axis of symmetry, all right, with my chicken scratch right there. So we could ask a simple question. For example, between f of x and g of x, which one has a greater y-intercept? Well, I could look at f of x, I could look at the equation of f of x, the equation of g of x, and I could know right off the bat that f of x has a larger y-intercept than g of x, right? And that's because I'm just comparing the two equations. I can also make my perspective more graphical, right? For example, I can observe on the graph that the y-intercept is 0, 12. And then for g of x on the table, I can see that the y-intercept, I look for x equals 0. The y-intercept is 0, negative 5. So 12, the value 12 is larger than the value negative 5. So there I'm comparing a graph to a table. With all of those forms, I can tell that the y-intercept for f of x is larger. All right. Let's take a look at another one. So what if I were to compare the x-intercepts? So I could say, which of the two functions has the smallest x-intercept? Well, I can't tell from the equation yet. Soon I'll be able to tell from the equation what the x-intercepts are. But for f of x, I can look at the graph and I can see that the smallest x-intercept is x equals negative 4. All right. Now, I'm going to look at g of x and try to find the x-intercepts. And really all I need to look for are these, look in the table. I'm going to look for these points where the output is 0. All right. So I can also find the x-intercepts on the table. All right. There's an x-intercept of 1, 0, and an x-intercept of 5, 0. So therefore, both of these x-intercepts are larger than than both of the x-intercepts from f of x. So right here, I would simply respond, if I'm asked about which one has the smallest x-intercept, I'm going to have to go with f of x on this one. X equals negative 4 is the smallest x-intercept. Both of the x-intercepts for g of x are larger. All right. Also, x-intercepts are called roots. So once again, I'm bouncing back between the table, the graph, and the equation. All right, trying to make sense of all of them. A third item that we could study is we could talk about the vertex. All right. So for example, I could ask which vertex has a higher output, right? Which vertex is greater? And when I say which vertex is greater, I'm really referring to the y value. So which vertex has a higher y value? Well, the vertex for f of x has a y value of negative 0.25. If I look for the vertex on g of x, well, I've only got the table. Okay, so if I look for that vertex, what I'm going to want to do is I'm going to locate those zeros again. All right, remember I had 1, 0 and 5, 0. And I'm going to go to the point that's directly in between those two. So that tells me that 3, 4 is the vertex of this function, all right, with the output being 4. Now, if you look at this list of numbers, 4 is the largest number that you get for g of x. Every other number is smaller than that, all right? So that tells you 4 is the largest of all of its outputs, and it is also larger than the output for the vertex of f of x. So that's me comparing the vertices. I can also graph this. I can go ahead and try to graph it, and that confirms to me that indeed that vertex is larger than the vertex for f of x. That's a comparison.